Well, it turns out black holes might not be as elusive as we once thought. They might be hiding within stars. In this case, the extra mass of some of these space lanterns could explain weird gravitational effects in the universe. Previously, dark matter was the cause of these phenomena. The black holes I'm talking about might be those itty-bitty ones that appeared at the dawn of time when the universe was just a baby. And they may still be lurking in the hearts of giant stars. A team of scientists say the idea might be quite plausible. Astronomers could detect such trapped black holes by the vibrations they produce on their stars' surfaces. And if there are many of them out there in the cosmos, they might function as the very dark matter that holds the universe together. Almost any black hole was once a massive star that collapsed in on itself and became incredibly dense. Black holes have immense gravitational pull. Even light can't escape their clutches. People often think that black holes work like vacuums, pulling space inside. But that's not the case. Black holes can only swallow stuff that is extremely close, usually space objects venturing into their event horizon. That's a black hole's point of no return. Once you cross this border, there's no escape. In 1971, renowned physicist Stephen Hawking suggested another origin of black holes. If we took the thick soup of particles that appeared moments after the Big Bang and the birth of the universe, we'd be bound to find some spots dense enough to collapse and create black holes. Such holes, which got the name of primordial black holes, could range in size from microscopic to gigantic. If they were pervasive and numerous enough, primordial black holes could act as dark matter, knitting the cosmos together with their enormous gravity. And dark matter is believed to make up 85% of all the matter in the universe. So what's the matter? Astronomers have been searching for primordial holes by looking for flashes that would occur when they pass in front of distant bright objects, magnifying their light like a lens. But they haven't spotted even one yet. On the other hand, if a primordial black hole was tiny enough, with a mass like that of an asteroid and a diameter as minuscule as a hydrogen atom, the flashes wouldn't be bright enough to be detected by such surveys. Then the team, researching the phenomenon of primordial black holes, decided to consider the consequences of a universe where dark matter was made entirely out of tiny black holes. They concluded that one of such teensy holes could be dashing through the solar system at any given time. Some might occasionally get trapped within gas clouds, giving birth to new stars, ending up in their centers. The next step of the researchers was to build a model of a black hole existing in the very core of a star, where hydrogen atoms undergo fusion and produce light and heat. At first, they didn't see anything unusual. Even a super-dense stellar core is mostly empty space, and it wouldn't be easy for a microscopic black hole to find matter to consume there. That's why its growth would be incredibly slow. It could take longer than the lifetime of the universe for this tiny hole to eat a star. But what if a larger hole, as massive as the dwarf planet Pluto or asteroid Ceres, appeared at the center of a star? Then it would get bigger in a matter of a few 100 million years. The material would keep spiraling into the black hole, creating a disk that would heat up because of friction, emitting radiation. Once the black hole grew to the size of Earth, it would start emitting even more radiation, shining extremely brightly. It would also be churning up the star's core, and the star itself would turn into a black hole-powered rather than a fusion-powered object. Such entities were dubbed Hawking stars. To cool off, the exterior of a Hawking star would form a red giant. That's what our Sun is likely to turn into as it gets older. But a red giant star with a primordial black hole at its center would be cooler than the stars that have reached this stage through regular means. Such stars are known as red stragglers. To find out whether they indeed host a black hole, astronomers might need to tune into the frequencies at which stars vibrate. Since a Hawking star would mostly affect the interior of the star rather than its topmost layers, the star would thrum with a certain combination of frequencies. The waves created in the process could be detected in a way the star's light would pulse and throb. So, all scientists need to do now is study the already known red stragglers and figure out whether any of them show the characteristic vibrations of a black hole. Now, should we worry about the Sun? Since our star hasn't reached its red giant stage yet, we can't know whether it'll turn into a cool red straggler. What we know, though, is that our star might contain those tiny black holes that formed in the Big Bang. But now, we have no means to check whether they're indeed there. Currently, our star is around the midpoint of its existence, middle age. It creates energy non-stop by fusing hydrogen atoms within its core. Once it runs out of hydrogen in its core, it will enter its red giant phase and begin to collapse. It'll happen in about 5 billion years, don't hold your breath, and the phase itself will last for 1 billion years or so before our star depletes its fusible materials and loses its outer layers. It will leave behind a tiny white dwarf star half as massive as the Sun and around the size of our planet. In some cases, when the gravitational collapse of a star's core is complete, the star remnants turn into a black hole. But that's not the fate awaiting our Sun. You see, our star just doesn't have what it takes to become a black hole. It's not heavy enough. There are a few conditions that can affect whether a star can turn into a black hole, including its composition, rotation, and the processes that lead to its evolution. But the main requirement is still the right mass. Stars with 20 to 25 times the mass of the Sun can potentially experience the gravitational collapse needed to form black holes. In other words, the Sun is simply too small to form a black hole. But what would happen to us if it did? You might assume that if the Sun turned into a black hole, our planet would be doomed to be pulled into it. But do you remember the basics? Black holes aren't giant space vacuum cleaners, just sitting there and waiting for a new planet or star to get their hands on. Mwah. But black holes don't have enough gravitational force beyond that created by their incredible mass. And if the Sun were to turn into a black hole, which will not happen, this hole would still have the same mass as our former star, and Earth's orbit around this newly formed black hole wouldn't change. But all other things would change dramatically. The Sun, which is currently around 432,000 miles in radius, would shrink to a mere 1.9 miles in radius. But you wouldn't be concerned with the absence of the bright yellow sphere in the sky, since you have many more pressing issues on your hands. Our planet's main heat source would be gone, leaving us frozen in the dark. Without this source of energy, photosynthesis would immediately stop, disrupting entire food chains. Eventually, all life on Earth would be extinguished. But rest assured, our hard, barren rock of a planet would continue in its orbit. Oh well. Well, space just hit us with its hugest black hole collision ever. What? You didn't feel that? Well, actually, you weren't supposed to. Two absolutely massive black holes spiraled into each other and smashed together, forming a brand new black hole about 225 times the mass of our Sun. This space catastrophe must have been epic, and if Earth had been in the way, it would have obliterated in a fraction of a second. Whew. Now, this whole event happened on the outer edges of our Milky Way galaxy, and we only caught it because of a team of super-sensitive space detectors called LIGO, Virgo, and Cagra. Now, these aren't new pop stars, and not even telescopes. They're more like giant cosmic microphones. They listen for gravitational waves, ripples in space-time that spread out when huge objects crash into each other. It feels like space is shuddering from the impact. Now, Einstein predicted such things way back in the day, and in 2015, scientists finally proved he was right. That win even scored them a Nobel Prize. So, the two black holes that collided were around 100 to 140 times the mass of our Sun. That might not sound like a big deal until you realize one thing: they're not supposed to exist. There's this weird range called the mass gap, roughly between 60 and 130 solar masses, where theory says black holes can't really form. Because when massive stars go out, they usually explode into supernovas that blow away most of their mass before anything can collapse into a black hole. So black holes in this range shouldn't be here, and yet here they are. This is actually the second time we've seen black holes lurking in this mass gap. The first time we detected such an event in 2019, two truly huge black holes slammed together and formed one 142 times the mass of the Sun. That's a big boy. It happened 7 billion years ago. To put it in perspective, Earth is around 4.5 billion years old. Anyway, two black holes slammed into each other in deep space. One was about 85 times the mass of our Sun, the other 66 times. And when they crashed, they merged into a brand new cosmic monster, a 142 solar mass black hole. At the time, it was the biggest black hole collision ever caught. Now curiously, physicists weren't even sure black holes this massive could even exist. Scientists had this idea that stars that big would just explode and fizzle out, not become black holes. So this collision basically walked in, broke the rules, and left everyone rethinking the textbook. Now, fast forward several billion years. Hey, it's Brightside, we can do stuff like that. After traveling across space for longer than the Sun has ever been around, the ripple from that crash finally reached Earth. On May 21, 2019, it hit the LIGO detectors in the US and Virgo in Italy, shaking their laser setups for about a tenth of a second. One little cosmic bump, and suddenly scientists had proof those giant black holes were real. As for that missing 9 suns worth of mass, it turned into pure energy in the crash. That's what powered the gravitational wave strong enough to hit us after 7 billion years on the road. By analyzing the wave's shape, basically its wiggles, researchers could figure out exactly what kind of black holes were involved and how massive they were. We could compare it with hearing the faintest echo of a giant cosmic drum solo and being able to tell what kind of drumsticks were used. Now, in any case, every time something like this happens, it pushes scientists to rethink the rules of how black holes are born. The leading theory now is that such giants don't come from dying stars at all. They probably form when other, smaller black holes merge again and again, like cosmic Lego bricks, snapping together over time. Normally, black holes fall into two camps. There are stellar mass black holes, a few to a few dozen times the mass of the Sun. When a massive star, like 8 times heavier than the Sun, burns through its fuel, it doesn't just fade away. It collapses, rebounds, and explodes in a supernova. What's left behind depends on how massive it was. Medium big ones leave behind a neutron star, an ultra-dense remnant of a star. But if it were 20 times the Sun or more, it collapses all the way down into a stellar mass black hole. Now, most of the stellar mass black holes we've spotted are the clingy type, paired with stars. Some suck gas from their partner stars and light up in X-rays. We call those X-ray binaries. Thanks to those dramatic duos, we've found around 50 black holes in our galaxy so far. But scientists think there could be up to 100 million lurking quietly in the Milky Way. So yeah, we're surrounded. Next, there are supermassive black holes, the behemoths, chilling in the center of galaxies, millions to billions of solar masses big. Almost every big galaxy out there, including our own Milky Way, has a supermassive black hole. Our own galaxy's own heavyweight champ is Sagittarius A star. It tips the cosmic scales at about 4 million times our Sun's mass. That sounds huge, but compared to other galaxies, it's kind of a lightweight. Take the black hole in the galaxy Holmberg 15A, for example. It's got at least 40 billion suns worth of mass. Ooh, that's a big boy. How these mega monsters got so huge is still a mystery. Some faraway galaxies show us that supermassive black holes formed super early, like within the first billion years after the universe was born. One idea is that they started out as giant stars, collapsing in the early universe. Scientists know that these giants keep getting bigger by gobbling up smaller stuff, like stars, neutron stars, and even smaller black holes. And when galaxies crash into each other, their black holes can merge too, creating even bigger beasts. But the ones in the middle, the so-called intermediate mass black holes, are the unicorns. Rare, weird, and super hard to spot. That's why this new collision is such a big deal. It might finally be solid proof that these elusive in-betweeners are out there. So, how do we even know this record-breaking black hole crash happened? Well, it all started on November 23, 2023, when two ultra-tiny ripples in space-time passed through Earth. They were picked up by LIGO, the Laser Interferometer Gravitational Wave Observatory, which has two massive detectors, one in Louisiana and one in Washington. These places are like giant cosmic tuning forks, just listening for spacequakes. Each LIGO detector has two 2.5-mile-long arms in an L shape, with laser beams running down both sides. If a gravitational wave, like the one from a black hole crash, sweeps through Earth, it stretches space in one direction and squeezes it in another. That slightly messes with the timing of the laser beams. And even those microscopic changes are enough to signal that something huge just happened out there. Now, the signal they caught this time wasn't your everyday ripple. It was complicated because the two black holes involved were not only massive, but also spinning like crazy. And that's a big problem for astronomers. You see, when black holes spin super fast, the math behind tracking and understanding them becomes way messier and harder to pin down. So when scientists try to match this wild signal to their models, simulations of different black hole collisions, they didn't get one clear answer. Instead, they received a bunch of possible scenarios. What they do know is this: the black holes were huge, and one of them might fall into that mass gap zone again, that mysterious range where black holes aren't supposed to exist. But because the spin throws off experts' calculations, well, they can't say for sure. To get clearer answers, scientists need better models, and to build those, they need more examples of these rare, high-spin black hole mergers. Thankfully, that's not impossible. LIGO, Virgo, and KEGRA have already detected around 300 black hole collisions since they started in 2015. And just in their latest run, 200 mergers. But here's the thing. This whole operation could be in danger. Unfortunately, LIGO is facing serious budget cuts, which might shut down one of its detectors. According to its director, without both detectors running, catching these once-in-a-universe signals could become near impossible. So yeah, we're getting better at hearing the universe whisper, but there's a chance we might have to start plugging our ears, just when it's getting interesting. Okay, let's just say you're driving home and suddenly your GPS freezes. Your phone says you've got full bars, but it takes forever to make a call. Or maybe the call drops for no reason and you have to redial. You brush it off. Probably just your carrier being weird. But then, later, during a house party, your light flickers for a second. No need to panic, you're not haunted by a ghost. At least I hope not. No, it's much more likely that the sun is acting up. Because a giant hole about 500,000 miles wide opened in its atmosphere, and now it's sending strange stuff straight at us on Earth. Okay, so what does that even mean, a hole in the sun? Well, when we look at the sun with highly protective sunglasses, of course, all we can see is a bright, calm star. But that couldn't be further from the truth. Up close, it's total chaos. Its surface boils with magnetic storms. The loops of plasma twist and snap, and every now and then, the outer layer, called the corona, becomes unpredictable. That's what happened recently when a massive region of the sun's atmosphere suddenly changed shape. So scientists call it a coronal hole, but don't picture a crack or a crater. It's more like an open vent in the sun's outer layer. Our star has these invisible forces running through it, like tension lines beneath the surface. Most of the time, they loop back on themselves, but sometimes, in certain spots, they stretch outward into space like open lanes. And that's when stuff starts flying. Particles shoot out at crazy speeds in what we call the solar wind. This wind hurls through space at about 1 million miles per hour, which is fast enough to reach Earth in a few days. The area of the Sun where the wind comes from looks darker and cooler than the rest of it. That's why we call it a coronal hole, and the current one is huge, so big that you could fit about 62 Earths side by side. It stretches across a massive chunk of the Sun's southern hemisphere and is pointed straight at our planet. So, what exactly is the Sun sending our way, and what happens when it gets here? Well, solar wind isn't just fast. It's also packed with tiny charged particles the Sun hurls out when it's feeling active. And when that stream runs into Earth's magnetic field, it's like tossing a rock into a still pond. It presses against our planet's magnetic shield, distorting it like a balloon being poked from the outside. That's what creates these breathtaking auroras. However, sometimes, the Sun takes it even further. Instead of a steady stream, it blasts out a massive cloud of solar material all at once. That's called a coronal mass ejection, or CME. This can mess with GPS and jam signals. It's partly because of something called the ionosphere, a charged layer way up in Earth's atmosphere that helps radio signals travel. When that layer gets disturbed, signals start bouncing weirdly or dropping out completely. In late May 2025, Earth was hit by a geomagnetic storm. It was classified as a G3, which means strong. It came from a stream of high-speed solar wind released by a coronal hole and caused visible auroras as far south as Iowa and Oregon. Warnings issued pointed to GPS and shortwave radio disruptions during the storm, but no serious issues were reported. Just a few days later, the situation got worse. On June 1st and 2nd, another storm happened. This time, it was a G4 class. That one is considered a severe level event, just one step below the highest category. The skies lit up. People across the northern U.S., and even as far south as California and New Mexico, saw glowing curtains of green and pink across the night sky. It's the kind of thing you normally have to travel to the Arctic or Antarctic Circle to see. Okay, fine, I'm convinced. Ghosts don't do this stuff. But it wasn't just a light show, although even astronauts aboard the International Space Station were able to capture breathtaking pictures. Airlines received radiation warnings and may have altered some flight paths as a precaution. Satellite operators were monitoring for signal drift, and high-frequency radio used by ships, planes, and amateur operators could have experienced brief disruptions. But then came another one. A few weeks later, in mid-June, Earth was hit by a G2-class geomagnetic storm. It wasn't as intense as the earlier G4 event, which meant less risk for disruptions and another chance to catch glowing skies on camera. Then, just to keep things interesting, the Sun followed it up with a pair of powerful solar flares on June 17th and 19th. Solar flares are distinct kinds of outbursts, but with similar consequences. The Sun's surface is constantly moving, dragging magnetic fields around like tangled cords. Eventually, those lines get twisted so tightly that they snap, and that snap is what causes a solar flare. If a CME is the Sun launching materials, a solar flare is more like the Sun flipping a light switch, except the light is radiation, which floods space at the speed of, well, light. Flares hit fast, sometimes within minutes, and they don't need to carry particles to cause problems. So, while CMEs are like massive clouds of solar blasts that take a day or two to arrive, solar flares are the flash that hits you before you even see it coming. And in mid-June, Earth got hit with two of them, one after another. The second one was the stronger one and briefly knocked out radio communications across parts of the U.S. Why is all this happening? It's not random. The Sun follows a pattern. It goes through phases, kind of like moods. Yeah, solar moods. Every 11 years or so, it gets a little dramatic. More flares, more sunspots, more weirdness. Scientists call this peak period the solar maximum, and we are currently in the middle of one. Right now, we're in solar cycle 25, which is expected to peak sometime between now and early 2026. During this time, the Sun's getting active. It seems like things are just starting to heat up, and we can expect even wilder storms in the coming months. But if that's the case, should we be worried? Well, not really. At least not in a run-for-the-bunkers kind of way. Solar storms don't hurt people directly. You're not going to get sunburned through your roof or microwaved in your sleep. Unless they announce a beautiful aurora, you won't even know it happened. The bigger concern is for the systems quietly running in the background – satellites, navigation networks, and electricity. When the magnetic field gets disturbed, it can cause electric currents to form on the ground. And those currents don't just stay underground, they can sneak into power lines. If those currents get strong enough, they can overload transformers, damage electrical systems, and even knock out entire power grids. That's what happened in Quebec in 1989, when a solar storm blacked out the whole province in 90 seconds. So that's why agencies like NASA and NOAA track solar activity constantly. They know when something's headed our way, how strong it might be, and what kind of warnings to send out. Now, we usually don't think about the sun unless it's too hot or messing with our beach plans, huh? Or when it's freezing and we're stuck indoors, dreaming of summer. But occasionally, it reminds us that it's still a wild thing. A fascinating ball of chaos. It flares, it erupts, it throws giant waves of charged particles across space just to see what happens. And even from 93 million miles away, we feel it. A dropped signal, a beautiful glowing sky, a power flicker. Little hints that we're not as disconnected from space as we'd like to believe. So, the next time your GPS acts weird or your screen glitches for no reason, don't blame your phone or Casper. It just might be the sun feeling moody again. Imagine a black hole, a terrifyingly dense space object pulling inside everything that comes too close. Nothing can escape its clutches, even a beam of light. And now, imagine two of these space monsters colliding. Scary? You bet. Astronomers have spotted two supermassive black holes feasting on the cosmic material of two merging galaxies in distant space. This phenomenon is the closest to colliding black holes we have ever seen. Supermassive black holes are the largest among all black holes out there. Their mass can be hundreds of thousands or even millions to billions of times larger than that of our suns. And two such giants have been recently spotted with the help of an array of telescopes in northern Chile's Atacama Desert. Astronomers originally used these telescopes to watch two merging galaxies located approximately 500 million light-years away from Earth. Thanks to being alert at all times, scientists have also noted that two gigantic black holes were growing alongside of each other. Apparently, these black holes came across each other when their host galaxies collided. One of the black holes is around 200 million times the mass of our Sun, and the other is a bit smaller, only 125 million times larger. Now, we can't see black holes directly. If you were to travel to a black hole, you wouldn't notice it until it was too late. The only detail that would give away the approaching black hole would be a slight blurring of distant stars due to the hole's gravitational lensing effect. The two black holes we're talking about are no different. They aren't visible directly, but are surrounded by bright clusters of warm glowing gas and stars. All of this has been tugged close by the black hole's gravitational pull. Time will pass, and these black holes will start circling each other. And eventually, they will collide, creating one, probably even bigger, black hole. Scientists have been observing these black holes across multiple wavelengths of light and have come to the conclusion that they are unique. They're located the closest to each other astronomers have ever seen. The distance between them is a mere 750 light-years, which, astronomically speaking, is just next door. Even more exciting, this distance is close to the limit of what modern technologies can detect. The thing is, such ginormous merges are more typical for distant galaxies. This makes it harder for Earth-based telescopes to see them. But the sensitivity of ALMA helped astronomers observe those bright and compact regions where matter swirls around the black holes. Imagine how surprised astronomers were when, instead of one black hole, they discovered two of them, munching on the dust and gas stirred up by the massive space merger. Galaxy mergers are way more common in the distant universe than in our neighborhood, and this discovery may mean that such black hole binaries are likely to be much more common than we previously thought, too. And if pairs of black holes are so common, it might make it easier for us to study gravitational waves. These waves, also known as ripples in space-time, occur when black holes collide. If we talk about the recently discovered pair of black holes, it might still take them several 100 million years to crash into each other. But by observing their behavior, scientists can figure out how many binary black holes there are that are about to collide in the universe. Also, this may give us more insight into what is going to happen when our home Milky Way galaxy collides with the Andromeda galaxy in around 4.5 billion years. By the way, the first photo of a black hole was taken in 2019. An international team of scientists, consisting of more than 200 astronomers, had been working for years to get this result. And their efforts finally paid off. The object in the photo is about 55 light-years away from Earth at the center of the galaxy M87. You can now admire this amazing space phenomenon thanks to the work of a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. The event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape. To capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, they were constantly monitoring the amount of moisture in the air, since too much humidity would ruin the images. To keep the chances of rain to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. All in all, the process resembled a carefully coordinated dance. But thanks to these preparations, in over 2 weeks, the telescopes collected 5,000 trillion bytes of data. It was then processed by several supercomputers, and scientists finally got the long-awaited images. And what they observed was a monster of a black hole measuring about 25 billion miles across. Now, how about we talk about the coolest black hole facts? There are baby black holes called primordial, and they're really tiny. They vary from the size of an atom to that of a mountain. There is a theory that galaxies get formed around black holes. This means that when a large star explodes, a black hole appears in its place, and then the rest of the galaxy just forms around it. There is a supermassive black hole right in the middle of the Milky Way galaxy. Its name is Sagittarius A star, and it's 4 million times as heavy as the Sun. And nope, we're not going to be pulled into this hole. It's more than 26,000 light-years away from Earth, and that's too far for this monster to have any influence on our planet. Besides Sagittarius A star, there are 100 million medium-sized black holes in our galaxy. And can you imagine how many black holes in total there are in all 100 billion galaxies that exist out there? You do the math. If you ever find yourself near a black hole, be ready that time will slow down significantly. It may work for you if you aren't so eager to grow older. Just don't let yourself be tugged into the event horizon. Whoops! Bye-bye. Black holes aren't some hungry predators that roam the universe preying on poor, unsuspecting planets. They just gulp down the stuff that ends up too close to them. On top of that, they sometimes fling out spitballs the size of a planet. How does this matter escape the pull of black holes? Well, typically, it manages to slip away before going past the point of no return. In fact, with Sagittarius A star, we should be worried not about its gravitational pull, but about the very spitballs. After all, the monster black hole hurls them in the direction of Earth at a speed of 20 million miles per hour. What if, one day, one of them reaches our planet? If you managed to squeeze Earth to the size of a cherry tomato, it would turn into a black hole. In fact, you could also become one if you agreed to be scaled down to an atom. South African astronomers have recently come across another head-scratching black hole mystery. In a region of distant space, they noticed that several black holes, located in different galaxies, aligned in the same direction. It looks as if their gas emissions have been synchronized by design. Nowadays, scientists can't explain why and how black holes, which are about 300 million light-years away from one another, can be acting in unison. It's a puzzlement.
Black holes are massive, the densest objects in the universe. They have such a great mass that their gravitational pull doesn't let anything, even light, escape their clutches. But in this terrifying world of black holes, there are monsters that are in a league of their own. Recently, astronomers discovered a black hole that is 33 billion times as heavy as our Sun. This space giant sits at the center of a supergiant elliptical galaxy called Abell 1201, which is located 2.7 billion light-years away from our planet. This black hole is so large it was given a rare designation, an ultra-massive black hole. No wonder. It's more than 8,000 times heavier than the supermassive black hole at the center of our home Milky Way galaxy. This ultramassive black hole was the first one to be discovered with the help of gravitational lensing. This method is based on the fact that very massive objects such as galaxies bend the light from a more distant object, magnifying it. A great thing about this method of research is that it allows astronomers to study inactive black holes too. It could help us detect loads of new black holes beyond our universe. That's what the area surrounding our galaxy is called. Probably it would help us find some exotic objects we've never seen before. Now, let's speak about another awesome instrument that efficiently helps us explore space, the James Webb Space Telescope. When it stares at young galaxies, which would look like mere red specks to you, it sees an astonishing number of cyclones churning at their centers. Those are black holes. Interestingly, giant black holes were believed to be big players in early cosmic history. But James Webb regularly finds an unexpected number of these beasts. For example, using the telescope, astronomers have detected a supermassive black hole from when our universe was less than 600 million years old. In universe terms, it's just a baby. This is the most distant actively feeding supermassive black hole ever observed. It's located at the heart of its host galaxy called Ceres 1019. The black hole is surprisingly small and not massive at all. It's actually one of the smallest found in the early universe. It's equal to approximately 9 million suns. It might sound like a lot, but in reality, supermassive black holes tend to grow to billions of times the mass of our star. There's another unusual thing about this find, and scientists are having a hard time trying to explain it. You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. The development happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.3 million times the mass of our Sun, are supposed to be seen in the more recent universe. Actually, scientists have long suspected that supermassive black holes probably existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It's shown that the black hole Ceres 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust, falling inside them, called accretion disks. The gravitational force of a black hole heats this matter, and it makes the disk shine. And that's not all. Extra strong magnetic fields produced in this process channel the matter to the poles of the black hole. From time to time, this matter is released into space in twin, powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. Astronomers were watching the galaxy hosting the unusual old black hole as part of the Cosmic Evolution Early Release Since survey. They saw the galaxy as it was when our 13.8 billion-year-old universe was just 570 million years old. Besides the super old black hole, scientists spotted two other ones. Those probably appeared 1 and 1.1 billion years after the Big Bang. They also discovered 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. Now, how about having a look at the biggest black holes astronomers have found so far and finding out what would happen to Earth if one of them was to enter the solar system? NGC 6166 is a monster that has grown to have a mass of 30 billion solar masses. It's an elliptical galaxy that has an active nucleus at the center. It's also one of the most luminous sources of X-rays. The galaxy's supermassive black hole powers two symmetric radio jets in the opposite direction, which is the result of the infall of gas into its center. Another peculiar thing about NGC 6166 is that it shows a blue shift, which means it's moving towards us. Is it time to pack up and move out of our solar system? The next supermassive black hole is located in the constellation of Draco, approximately 10.4 gigalight-years from us. The mass of this supergiant is more than 30 billion solar masses. Besides being incredibly massive, the black hole is also really big. If it replaced our Sun, the diameter of this hole would extend to the orbit of Pluto. The next black hole is one of the most interesting on our list. It has a mass of 40 billion solar masses and is actually a blazar. It's the most energetic of all quasars, super bright distant objects. The blazar's luminosity is 300 trillion times that of the Sun, and more than 25,000 times as great as the luminosity of all 100 to 400 billion stars of the Milky Way galaxy combined. But since the distance to this quasar is about 12.1 billion light-years, we can't see it directly. But we know that the central black hole of the quasar consumes huge amounts of matter, about 4,000 solar masses of material every year. IC 1101 is a supergiant elliptical galaxy. It's the most massive known galaxy so far. Since this galaxy is elliptical, it isn't filled with gas. That's why the star formation in that region is very low. As for the black hole at the center of this galaxy, it lies in the mass range of 40 to 100 billion solar masses and emits clear radio signals. But wait for this champion. Astronomers have discovered a gravitational space wonder that has grown to really unimaginable proportions. The black hole I'm talking about is TON 618, and it's a mind-boggling 66 billion solar masses. Yep, we've got another ultra-massive black hole here. Imagine gathering all the stars in our home Milky Way galaxy and squishing the matter they're made of into one black hole. And it still won't be enough to create a TON 618. If this monster of a black hole replaced the Sun, its radius would be more than 40 times the size of Neptune's orbit. You know that black holes are incredibly dense, but it doesn't mean they're some kind of space predators roaming galaxies and munching on everything they come across. TON 618, for example, still has a whole galaxy filled with stars and other stuff happily orbiting it without getting pulled inside. So the perception of black holes as giant vacuum cleaners is wrong. In reality, it's incredibly hard to grow a black hole. Try and you'll see. And now, what if a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved a bit closer to our solar system? The answer is simple. We'd be doomed. The distance between this huge thing and Earth would be several dozens of light years, and still, it would wreak total havoc on our planet. Earth, along with other objects making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity. But you can relax and breathe out. Such massive black holes stay away from us at the moment. Imagine a powerful giant, like the Sun, clashing with a tiny yet mighty opponent, a small black hole. The collision is imminent, and the fate of the solar system hangs in the balance. Will the Sun be able to withstand the intense gravitational pull of a tiny black hole, or will it be swallowed whole? The answer lies in the forces at play in this mind-blowing cosmic collision, so let's break them down. First of all, what is a black hole? A black hole is a region of space where the gravity is so strong that nothing, not even light, can escape from it. Like a cosmic vacuum cleaner, it sucks up anything that gets too close. It's so massive that it warps the fabric of space-time around it. Black holes are one of the most scary and mysterious objects in the universe, a powerful force of nature that defies our understanding of physics, a true enigma of the universe. Black holes come in different sizes, from small ones that are only a few miles wide, to supermassive ones that are billions of times the mass of the Sun. Most of them are formed by the collapse of massive stars. After the black hole is born, it starts to grow in size by eating everything in its path. And if two or more black holes collide with each other, they can merge into one enormous cosmic monster in a terrifying dance. But what about the smaller ones? The smallest known black holes are called stellar black holes. It's a type of black hole that weighs 3 to 10 masses of our Sun, while being very small. It's like taking all the matter in the solar system and squeezing it into something the size of New York City. And yes, it's considered very small. Just for comparison, intermediate mass black holes weigh between 100 to 1,000 solar masses, and supermassive black holes weigh millions or billions of solar masses while being unimaginably huge in size. So, stellar black holes are basically nothing compared to their relatives. Imagine a massive star, bigger than our own Sun and with a heart made of nuclear fuel, burning bright and hot. But as the star runs out of fuel, gravity takes over and starts to squeeze the star. The more it squeezes, the hotter it gets, until the star's core reaches a temperature of billions of degrees. Eventually, the core collapses under its own gravity. This creates a massive blast called a supernova. This collapse creates a singularity, which means a point of infinite density and gravity. This point is surrounded by an event horizon, the invisible line beyond which nothing, including light, can escape. And just like that, voila, a stellar black hole is born. Pretty mind-blowing, isn't it? Stellar black holes are the most common type of black holes we know of. These guys can be found all across our galaxy. So, what are the chances that such a little monster will come for our Sun? And in that case, what will happen to us? Well, actually, the likelihood of the Sun colliding with any black hole is incredibly small. It's almost impossible for it to happen. Even though stellar black holes are the most common type of black holes in our universe, they aren't common at all. The chances of the Sun and some black hole crossing paths is so rare, it's basically like winning the intergalactic lottery. Only this win wouldn't be that pleasant. For 2023, the closest known black hole in our solar system is Gaia BH1. It's about 10 times heavier than our Sun, and even this one is about 1,600 light years away from us, which is a quadrillion miles. So, it's safe to say that our Sun is not going anywhere anytime soon. But never say never, right? Just like with any astronomical event, we need to understand the different ways something like this could happen. For example, it would be possible if a rogue black hole passed through our solar system, much like a comet or asteroid passing by. Unfortunately, unlike comets and asteroids, black holes are invisible and can only be detected by their gravitational pull. So it's not like we'd see a big, ominous black hole hurtling towards us. Rather, we'd only know it was there if it caused some sort of disturbance in the orbits of nearby objects. So what now? We know that the Sun is a massive, luminous star at the center of our solar system. It's about 4.5 billion years old and has enough fuel to last for another 5 billion years. This star is so big that it's hard to even comprehend its size. In fact, if you were to put all the planets in our solar system inside of it, there would still be room for more. And it's so massive that it contains almost 100% of the total mass of the solar system. So it's hard to imagine how some insignificant small black hole thousands of times smaller than this star can devour it. And you're right, it won't. Well, at least not completely. So imagine if a rogue black hole arrived in our solar system and has begun to approach the Sun. As it gets closer and closer, the black hole's immense gravity will start to pull the material from the surface of the Sun. The Sun would start to get stretched and distorted. This is called spaghettification. Imagine a rubber band being stretched until it snaps. That's kind of what would happen to it. This gathered material will form a swirling disk around the black hole, called an accretion disk. As more and more material is pulled in, the disk will heat up and start emitting intense radiation. And as the Sun gets pulled in, it would start to release massive amounts of energy in the form of light and heat. The Sun would become much brighter and hotter than before. The Sun's outer layers would be vaporized, creating a massive cloud of gas and dust that would expand outwards. It would be like a cosmic fireworks show, but with terrible consequences. Even though it would be one of the most spectacular views in the universe, we wouldn't be able to see it. As you might have guessed, the Earth would be in for a really rough time. The intense radiation and solar material would cause massive wildfires, and the intense heat would vaporize the oceans. The Earth would be bathed in a constant stream of high-energy particles, and the atmosphere would be ionized. In short, the chances of any life surviving would be close to zero. And this collision would have far-reaching consequences not only for the Earth, but for the entire solar system. The intense radiation and heat would vaporize everything in its path. All the planets would be destroyed. Now, the Sun being a larger object than a typical star wouldn't be completely devoured by the black hole, but it would be significantly distorted and disrupted. The intense gravity of the black hole would cause the Sun's outer layers to be pulled away, creating a massive blast called a tidal disruption event. But either way, in the end, the black hole would win. It would grow in size, and a new accretion disk would form around it. As we've seen, the collision of the Sun with a black hole, whether it be a tiny or stellar one, would be an epic and catastrophic event. But thankfully, as we've already mentioned, the likelihood of such a collision happening is extremely low. However, that doesn't mean we should stop studying black holes and their potential impact on the universe. The more we learn about these mysterious objects, the better equipped we'll be to understand and predict their behavior. So, let's keep researching, exploring, and observing the depths of space. And who knows, maybe one day we'll come across a black hole that's just too curious and gets too close to the Sun. Let's hope by that time, we will already be living on other distant planets.
Now really, an object weighing billions of times the mass of our Sun must be easy to find, right? Wrong. Unfortunately, it might not be that simple, like in the case with a missing black hole. But let's travel to the galaxy cluster Abell 2261, hosting a supermassive black hole at its center. Or at least, that's where it's supposed to be. The main problem is this giant space phenomenon is nowhere to be found. Now, supermassive black holes are mega monsters, churning slowly at the center of their home galaxies. They gather tremendous clouds of gas and dust around them, which makes them swell up to sizes the human mind can't begin to imagine. If a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved even a little bit closer to our solar system, we'd be doomed. The distance between this huge thing and Earth could be several dozens of light years, and still, it would wreak havoc on our planet. Earth, along with other things making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity or longer. Hey, who knows, right? So, it's good that such black holes stay away from us at the moment. So let's see what happened to that runaway supermassive black hole from that gigantic cluster of galaxies around 2.7 billion years away from our planet. Scientists have been looking for it with the help of NASA's Chandra X-ray Observatory and Hubble Space Telescope. But so far, no result. The main problem with finding a black hole is that it's, black. And space is, you guessed it, black too. So there's no contrast whatsoever that could help astronomers spot the hole. But scientists haven't given up yet. After all, they have a lot of other technologies to find black holes, small and big, in the vastness of space. Some of these methods involve watching the stars orbiting black holes. Sometimes it's a faint gravitational wave signal, which is produced when two black holes collide. But the most reliable technique is watching dust and gas falling to their doom. The thing is, black holes are space objects with insane gravity. So regions of space surrounding them are usually a bit chaotic, gas and dust getting pulled into the bottomless abyss, compressing and heating up. In the process, it releases a flood of X-ray radiation. So, astronomers look for extremely bright X-ray sources in the universe. Chances are those are the last gasps of giant clumps of material before they disappear into a black hole. Then, why can't scientists find such X-ray signatures left by the black hole in Abell 2261? One of the most mysterious things about its disappearance is that radio telescopes have spotted some signs of massive plumes of superheated material launched at one point within the last 50 million years. These plumes were most likely caused by a large black hole, which is nowhere to be found these days. So, at the moment, we can only play a guessing game. Maybe two medium-sized black holes collided, pushing the newly merged giant out of the center of the galaxy. The observations of the stars in that galaxy have shown a clump of dense material a few thousand light-years away from the galaxy's core. Maybe it's the runaway black hole, but disappointingly, no X-ray signals are coming from that clump. Or the hole might still be there in its rightful place, but it's, slumbering. If it doesn't get a fresh supply of gas and dust, it has nothing to feed on. As a result, it can't release a flood of X-rays. But again, the answer, do not disturb, the black hole is sleeping now, isn't very satisfying. Why isn't it getting its space food? What happened 50 million years ago? What is that clump of material speeding away from the galaxy center? So many questions, and no answers so far. At least, we know what black holes look like. Well, kinda. It's actually the shadow of a black hole's event horizon, visible against the glowing superheated material falling inside the hole. The first ever mugshot of a black hole appeared in 2019, but the data for its creation was collected in 2017. It took an international team consisting of more than 200 astronomers 2 years to assemble the image. We can admire this amazing space phenomenon thanks to a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Why such a name? The thing is that the event horizon is a point of no return on the outskirts of a black hole. When something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape the black hole's clutches. Anyway, to capture that very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 powerful radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, to keep the chances of rain and bad weather to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. On each observation day, the telescope gathers roughly 350 terabytes of data. That's 10 times the amount of data collected every day at the Large Hadron Collider. But let's speak more about black holes themselves. There are stellar black holes, smaller but even more dangerous than their supermassive peers. They appear when stars that have run out of their star food fall into themselves. If a star used to be big enough, it keeps compressing and compressing some more, and voila! A baby stellar black hole is born. But even if I call such a hole a small one, It's still 5 to several tens of times heavier than the Sun. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 SUVs. One theory claims tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple mini black holes pass through our planet every day. There is a supermassive black hole smack dab in the middle of our galaxy, the Milky Way. Its name is Sagittarius A star, and it's 4.3 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light-years from Earth, too far to have any influence on our planet. By the way, recently, astronomers have discovered that this supermassive black hole might be leaking. If it's true, it probably means that Sagittarius A star isn't a sleeping giant, as previously thought. It might still be active. And the leakage recorded by scientists may be the hole hiccuping while swallowing clouds of gas. Maybe we should burp this baby? If you ever find yourself near a black hole, get ready that time will significantly slow down. It may work for you if you aren't eager to grow older. Just don't let yourself be tugged beyond the point of no return. Another danger of hanging around a black hole is that it might start behaving like a massive galactic volcano. From time to time, black holes flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short time ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Okay, mind blown, I'm out of here.